advance here. Let's continue our discussions on the properties of Fourier transforms. Now, this is our part 2. So now let us consider the fourth property, which is time differentiating property. Okay, normally if you differentiate time, you will get frequency. So this, if x of t, okay, has a Fourier transform of x of what? Omega, okay, then we will have, in terms of the time differentiating, d on dt into what? X of t. This is what? Time domain, and it's time differentiating because we are differentiating the time domain. Okay, we'll give what? J omega, which is frequency domain, into x of what? Omega. Okay, so this is what we have. Okay, so now here we will use the inverse. We will use the inverse Fourier. Okay, the inverse Fourier transform. Okay, we use the inverse Fourier transform. And in the inverse Fourier transform, we have what? X of t is equals to 1 on what? 2 pi, okay, into minus integral into what? Minus infinity to what? Infinity, okay, into x of what? Omega into ej what? T the what? The omega. Okay, so this is what we have. So now, if we have this, we differentiate both sides of the equation. So d on dt into x of t is equals to 1 on 2 pi into what? Minus infinity to what? Infinity. Okay, x of what? Omega. Then you differentiate this side, which is d on what? dt into what? E j what? T d what? The omega. Okay, so that's what we have here. Okay, so now here we're going to have 1 over what? 2 pi into integral infinity minus what? Infinity. Okay, if you differentiate this one, you get what? J omega. So we have that J omega here. We have this x of what? Omega. So here we'll get what? Ej what? Ejt the what? The omega. Okay, so now what you can see is that I can make this one here d on dt. Okay, x of what? T. So now what you can see here is that we can have j omega. If you take away j omega, the rest of the parameters that you see in this particular equation denotes what? X of t. Okay, because you can see that x of t is equals to what? This. So if you take away j omega, the rest is what? Is what? X of what? T. And we know that the transformation or the Fourier transformation of x of t also is what? X omega. So I can say that j omega into what? X of what? Omega. Okay, is the transformation for d on what? Dt, x of what? T. So let me write it properly for you. So in that case, what I'm having is that d of what? D on dt into what? X of t is having what? Fourier transform of what? J omega x of what? Omega. So this is the time differentiating property. Let's go to the next property. So the next property that we can talk about is the time integrating property. Okay, is the time integrating property. So let me say time integrating property. So that is property number 5. Time integrating what? Property. Okay, so in the time integrating property, if I have x of what? T, which is the Fourier transform of what? Which transforms into x of omega. Okay, then I'm going to have integral of minus infinity to t. Okay, which is x of what? Tau. The tau will give me Fourier transform, okay, of x of what? Omega. Okay, on what? On j what? Omega. Okay, on j omega. Okay, so now here, let's see how we can be able to prove this particular property. Okay, so to prove this particular property, you use the inverse Fourier, use the inverse Fourier transform. So in the inverse Fourier transform, we know that x of t is equals to 1 on what? 2 pi integral minus what? Infinity to what? Infinity. Okay, into what? X of what? Omega. X of what? Omega. Into e what? J omega what? T the what? The t. Okay, so that's what we have here. Okay, so now what we do is that we integrate both sides. Okay, so let me say integrate both sides. Okay, so if you are integrating both sides, then what you're going to get is that you're going to have minus infinity to t. Okay, into x of, let's say, tau, here the tau. Okay, is going to be equals to 1 on what? 2 pi into what? Into minus infinity to what? Infinity. Minus infinity to infinity. Okay, into the x of what? Omega. Okay, into the integral. Okay, into the integral minus infinity to what? To t of what? Of this particular part, which is e j what? T. Okay, d. Here is what? Here is actually omega. Sorry, here is supposed to be what? The omega. Okay, it's supposed to be the omega because here is omega. So the what? The omega. Okay, so now I'm going to have t into minus what? Infinity to x of what? Tau the what? The tau. Okay, the tau is going to be equals to what I have here. 1 over what? 2 pi into the minus infinity to what? Infinity. X of what? Omega. Okay, so here you can see that I am differentiating with respect to what? Omega. So if I'm differentiating with respect to omega, then in that case I'm going to have e into what? J omega what? T over what? Over over j. I'm going to have over what? J omega. Okay, over j omega. Okay, all right. So when I have this one, then what I'm going to do again is that I will just have to I can bring this one here. Okay, I can bring this one here, and then I can say that 1 over what? 2 pi into minus infinity to what? Infinity into x omega. Okay, I can bring this one here into what? J omega into e j omega what? T the what? The omega. Okay, all right. Okay, so that'll be what I can do here. Okay, I have to tell you something here. Okay, I have to tell you something here, that this place, I have to make it tau. Okay, tau. And then I must also tell you that I am actually, you see that I'm differentiating here with respect to what? Tau. And here is tau. So I'll actually differentiate here with respect to what? The tau. Okay, with respect to what? The tau. And then I must bring a bracket here. Okay, and here will become what? The omega. And here will become the omega. So that when I differentiate, so that when I integrate here, I'll get what? J omega. But if I integrate here with respect to what? The omega, then in that case, I'm supposed to get what? J what? Tau. I'll not be able to get what? J omega. So if I differentiate with respect to what? The tau, then I'll be able to get what? J omega. All right. What I am saying is that this place, I'm supposed to integrate with respect to, sorry if I've been confusing you with differentiation. Actually, I'm doing integration. Here, I'm supposed to integrate with respect to what? The tau, which is here. Okay, so that when I do that, I'll be able to get what? J omega. But if I integrate with respect to the omega, then I'll get what? J tau, which is not according to the answer. So I will integrate with respect to the tau, then I'll get what? J omega, which is here. So now if you check here, you see that all this one is the what? If you take away J omega, the rest of the terms here, okay, it is the what? It is equals to x of t. And we know that x of t is the what? Instead of x of t, we can write what? X of omega, because x of omega is the Fourier transform of what? X of t. Okay, so in that case, I'll be able to say that here into what? T minus what? Infinity. X of what? Tau the what? The tau is actually equals to x of what? Omega over what? Over j what? Omega. Alright. So that is how you're able to get this one. Thank you so much. Let's I think we can briefly see our next property. Okay, so let's see property number 6. Okay, so property number 6 is the frequency differentiation property. So let me say, so that's number 6, frequency differentiation property. Okay, so frequency differentiation property. Okay, so let's briefly see that one. So if I have x of what? T, which is the Fourier transform of what? X of what? Omega. Okay, then what I'm going to have is minus j what? T into x of what? T will be the Fourier transform of what? D of what? Frequency differentiation. So I'm differentiating the frequency. Okay, will be this one. Okay, so how can I be able to prove this one? Okay, to be able to prove this one, what I know is that x of what? Omega is equals to integral minus what? Infinity to what? To infinity. Okay, and then I have here x of what? T into e minus j omega what? T the what? The t. Okay, so now I'll just integrate, differentiate both sides. D on the t into x of what? Omega is equals to integral minus infinity to what? Infinity. X of what? T. And then I'll differentiate here. D of what? The t. D on the t into e minus j what? T the what? The t. Okay. So that is what I will have here. Okay. Please wait a minute. You see that here is x of what? Omega. X of omega. So I have to differentiate with respect to what? The omega. Okay, sorry. I have to differentiate here with respect to what? The omega. If I'm differentiating here with respect to the omega, then I must differentiate here also with respect to what? The omega. Okay, then I must differentiate here also with respect to what? The omega. Okay, alright. So this is what I'll have. So now here, d on what? The omega into x of what? Omega is equals to infinity to what? Minus infinity. Okay, so here what do I get? I'll get what? I'll get I'm differentiating with respect to what? The omega. So that means that I cannot get j omega again because I'm differentiating with respect to what? The omega. So that means I can get what? Jt. Okay, so I can get minus j what? T into x of what? T into e exponent what? Minus j omega t. Okay, so this the t you see here, it is with respect to this x of t. Okay, into what? The t. Okay, so now what you can see if you look at this one is that if you take away this minus jt, all the terms you have here is equals to this what? J omega. Okay, so all the terms you have here is equals to this j omega. All right, so now what I can do is that if I can have d on what? The omega into what? X of what? Omega is actually equals to what? Is actually equals to, or is the Fourier transform. It's better to write is the Fourier transform. You see that this this whole thing I have here, okay, is basically for x of what? Omega. Okay, if you take away minus jt, every other term you have here is what? X of what? Omega. Okay, and we know that x of omega is the Fourier transform for what? X of t. So instead of writing x of omega, I can write what? X of t. So I write minus j what? T, and here becomes x of what? X of t. Okay, x of t. Okay, and here is what? Is the Fourier what? Transform. Okay, because all the terms you have, if you take away minus jt, is equals to what? X of omega as here. Okay, and we know that x of omega is the Fourier transform of x of what? T. So instead of writing x of omega here, I can write x of t because the Fourier transform of what? X of omega, and I bring my what? minus jt. So this is what proves the formula. So I can just interchange and write minus jt into x of what? T, which is the Fourier transform, okay, of d on what? The omega x of what? Omega. Okay, so now you can see that what is here is the same thing as here. Thank you so much. See you in the next class.